Welcome to another episode of Debt Nation, where we are busy putting death out of business. We're going to put death out of a job, and it's James. He's here to help us do that. He's a field-trained mechanical engineer, and he's come up with this idea. He just gave a TED Talk. It's called Cube Spawn. James, welcome to Debt Nation. Very, very, very honored to have you on. We're very interested in this cube spawn idea here at Dead Nation because, as you see on the bottom of your screen, there's a thing called Project 222, and that's Mr. Holsopple's. He was a candidate for the USTP primary, for the US Transhumanist-Party primary, and his idea is getting food, shelter, and water to people all around the world. And it's one of these transhumanist ideas that if you can deliver basic services to people and lift people out of certain poverty circumstances, you can start. It's an enhancement on the world. It alleviates a lot of the social, societal, economic, environmental issues on people globally, including geopolitical factors. Now, this is a really important notion, but you've come up with this idea, Cube Spawn. But before we walk into Cube Spawn and discover its magic, let's just hear a bit about you, your history. You're a sci-fi guy, and then how you got into this idea of Cube Spawn. Take it away, James. Thanks for coming.
Oh, certainly. It's an honor to be here. Cube Spawn originated out of it's a long story about some fairly boring engineering stuff, so I won't go into the heavy details, but I worked on a implementation project for a transit system to put 700 computers on buses in San Antonio, Texas. It was a project very similar to a smaller project I worked on that had a lot of swarm robotics. And the idea is essentially the same. You got a bunch of transit vehicles running around generating data and coming back to a central point to be analyzed, or you got a bunch of swarm robotics running around generating data coming back to a central point to be analyzed. So that took place in about 2000. And about 2007, I'd been toying around with a whole bunch of different swarm robotics stuff, and the RipRap 3D printer came out. And it occurred to me that what really needed to happen was to take all of this whiz-bang network technology that was being used to manage vehicles and use it to manage small, affordable manufacturing machines. Because if you do that, then you can take the basis of the production of material goods and distribute it to everybody. The problem with automation is that it's primarily held by 50% of it's in the automotive industry, and the remaining 50% is distributed across electronics, the petroleum industry, pharmaceuticals, packaging, and nobody is using it basically because it's so expensive. And so if you can get automation into everyone's hands, what that leads to is a distribution of the ability to produce wealth. So having worked on all these projects, I thought it would be best if I applied that knowledge towards building something that was sort of universally valuable. And I have spent the last about 14 years working on mostly things not related to the project, mostly things related to getting the project funded. Because that
sounds like a familiar story here at Dead Nation. Mr. Holsopple came up with an incredible shelter device, and the university backed him even, and he struggled for funding. Funding is a funny thing in this world. Economic orientation is sometimes not orientated towards what's needed, but what's profitable and what can make a good business decision. Now, that's kind of tough, especially if you're trying to hold onto your patent, if you don't want to give away too much, too much of your intellectual property or your business model or whatever. It becomes harder, to do because sometimes they'll just play a waiting game. They'll just sit and they'll just try and wait you out and see. It's a war of attrition in that way. So no, it's interesting. Funding we'll go into that, but let's just talk a little bit more about it. So if I approached you on the street and I said, "Hello, sir. What is cube spawn? What will it do for me? What's
Right.
your elevator pitch to the world?"
This is going to sound strange, but it will do nothing for you at this point in time. But that's what the intent is, that it is a step in a fairly lengthy process. Right now, stuff is produced largely in China and then shipped all over the world. So the idea that these fabrication machines have some intrinsic value is a product of the commercial orientation of business. But in fact, what they have is enormous societal value, because the ability to produce things locally addresses this enormous range of problems that have nothing to do with the economy. What they do is they address the problems of waste, energy production, the cost of shipping, cost of labor, getting automation into ordinary people's hands instead of having it the domain of only mega corporations. So my elevator pitch is, I could sell you on the point that there are all sorts of vertical applications. So if you're making a product, you could use these to, reduce the cost of production on that product. But that really misses the point. The point is that these are intended to be applied as a much broader solution to a convergence point between an enormous number of societal problems. So these are really intended to be the Star Trek replicator as it would be implemented crudely in the 21st century rather than the 23rd.
Yeah. Because we haven't got to molecular nanobots yet. I mean, you're doing, instead of molecular nano machinery, you're doing upper scale, not quite nano, not yet. Anyway.
Right. Yeah.
But you would be the nanobot guy if the nano molecular machinery guy, if you could be, right?
Well, the thing about it is, if you implement this, it's very dynamic, which means that the first implementation is probably the worst one, and each subsequent one will become better. So the scale up and down in size by doubling. The basic cubes are 600 millimeters, and the reason that they're built to that size is that I live in a feet and inches supply chain in the United States. And so 600 millimeters, 300 millimeters is essentially a foot. And so when Britain converted over to metric, they went through that whole shakedown of figuring out how they could not have to replace $1.5 trillion worth of capital machinery. And so they decided, hey, look, a foot's 300 millimeters. Why don't we just change the scales? And instead of having to retool, you can use most of the same machines by changing the software, changing the setting, retraining the operator. And so I built everything at 300, 600, 1.2 meter, and 2.4 meter is the intended scale. And the 300 millimeter machine's a 1 foot machine. You think, well, what the hell are you going to build in a 1 foot machine that anybody's going to use? And I contend that you can build a very small pick and place line. You can do all sorts of manipulation of medical technology and produce products that are appropriate to insertion and placement inside of the human body. So very small machines are still very useful, and there is a number of things they can do. The ultimate goal is to eventually tunnel to nanoscale by bootstrapping from those small machines to ever smaller machines, and addressing all the problems of vibration isolation and metrology standards for accuracy and all of the other necessary steps. So these basic initial machines don't even begin to approach the scope. It's sort of a hard sell to people, because you have to look beyond what is contemporaneous. This step is not the whole idea. This step is an attempt to move towards what the practical realities are today, and also leave the door open for all the stuff that you can do with it tomorrow.
Yeah, that's. I
don't know if I answered your question.
Well, yeah, well, that's fine. With detonation here at Detonation, I mean, we talk about the fossil fuel industry all the time, and how it's how they have been an entrenched sort of system, entrenched sort of oligarchy, global oligarchy, that's been disrupting technology and innovation in the bad sense of the word, not in the good sense of the word, in the bad sense of the word. They've been hiding technologies. They've been, buying up things and putting them behind patent walls and regulatory frameworks that have allowed their regime to continue. And yours is a disruptive technology. It's also a disruptive technology in the labor market. Local manufacturing, that reminds me of Charles Hughes, right? The economist, who's always going on about local manufacturing. He's talking about the end of empire when you're coming back to you're a less integrated world. A lot of environmentalists, agree with this notion that there needs to be less cooperation on a material level between, let's say, China and the United States, which is these two largest shipping corridors in the world. Maybe apart from through the Persian Gulf or whatever. But basically between China across the Pacific there, and environmentalists say, well, it's just destroying the world. I mean, you load up these big ships to put plastic on it and to take these things across. But this is a hugely I can see this being hugely disruptive and disastrous for some of the entrenched systems that we have. Do you think so?
Well, yeah. If you look at the shipping industry as it stands today, the 15 largest container ships in the world once you're in international waters, there are no particulate or emissions regulations. So you can burn bunker C fuel, you can burn the worst fuel imaginable, and it's just fine. And so the 15 largest container ships produce as much emissions and carbon dioxide as all 770 million terrestrial vehicles. So, and there are 5,000 container ships on the registry. So if you really think about the air pollution problem, shipping is responsible for about 30% of the worldwide air pollution problem. And it's unregulated. They're still running it. In 1960, an automobile produced about 100 times as much emissions as it does today. Those regulatory systems that you have to put on them now don't add much to the cost of the vehicle, and they take 98% plus out of the waste stream that comes out of the car. Ships don't have them, and they're not required to have them. So they just pump it into the atmosphere. And so it's disruptive from the standpoint that reducing the amount of shipping, because something like 85% of all materials are already in the city where they're needed, in the landfill or in the waste stream. So the materials are already there. So if you recycle materials locally and fabricate all that short-lived products out of them, and then recycle them again, you do three beneficial things. You reduce the amount of waste and litter that goes around, you reduce shipping that you have to bring new materials in, and you lower the cost of products because you've recycled the materials locally. So all of those things are beneficial, and that's just one tiny facet of all of this. If you get rid of shipping on the one hand, then automation. The idea is that these machines should be as automated as possible so that ordinary people can benefit from automation instead of just these big companies. They use you to fill in the gaps in their automation, and they make 100 times as much profit. You benefit nothing. You're still working for the man. So if you have automation that's available in local communities, even small communities, and it's affordable, and it recycles materials, and you get rid of shipping, all of these benefits accrue to everybody instead of accruing to only a few corporations. 70 corporations are responsible for 90% of the world's pollution problem, and 30% of them are in the petroleum industry. So the huge problems that we have are really a byproduct of our distribution system. If we didn't have this distribution system, you also wouldn't have all this money accumulating in the 1%'s pockets that they can use for political influence. You distribute manufacturing, which is where most of the world's wealth is produced. Shipping and manufacturing together constitute approximately $20 trillion out of the $100 trillion world economy. So 20 trillion of that could evaporate in 3 years if people got on board and started building their own machines. That's why I've made these machines open source. I want everybody to have one. I want every community to have enough of them to satisfy their material needs. Because if they do that, you don't have to start a political movement. The politicians will be irrelevant. Nobody will be able to buy them because the accumulation of funds in the pockets of a very few people ceases to exist. You have the funds distributed across all of the communities that use material goods. And who is that? Why, it's everyone. So this disintermediates all of these middlemen and gatekeepers, and it puts the power. This is like a derivative. This is like centrifuging communism and just taking the good part out. The power goes to the workers, but in this case, you don't have to work because it's automated. And then you have all of these people using these tools who can feed back into it. So you solve a problem in Botswana, it applies in Boston. You know, you solve a problem in California, it's fine for Tibet. You can take and consolidate this network of human knowledge and problem solving. You know, and some farmer in the Philippines knows a hell of a lot more about what you got to do to get a water buffalo out of the mud than anybody else does, and he's going to come up with a solution that's appropriate to that problem, but it applies to anybody who has a water buffalo. So it's the kind of thing where specific, narrow, localized knowledge has a chance to propagate, and a lot of that propagation can be through the means of technology, which is completely neutral. If you go to the Pakistani-Indian border, you got people on both sides using cell phones. The technology is neutral. You know, the Indians and Pakistanis don't like each other. They don't get along. They don't trust each other. But everybody uses a damn cell phone. So if they all have the same kind of manufacturing machines, you're not going to run into an ideological or even a language barrier. There's no barrier to applying the solution, and you don't have to organize people under some political idea that 80% of them are going to reject out of hand because it doesn't fit their culture, it doesn't fit their language, it doesn't fit their expectations.
That is so
technology.
That is so clever, using open source for that distribution method. It's so clever. That is fundamental. You know, open source is one of the transhumanist ideas, and yeah, if you're going to take on some $20 trillion you know, embedded global infrastructure, yeah, open source will help you.
Don't fight them. Just render them irrelevant. Disrupt them.
Yeah, no, that's amazing.
Fighting them's painful, but disrupting them is effortless.
Yeah, heck yeah! Wow, that's amazing. So, how did you come up with this idea? What did you wake up in the middle of the night, or were you just part of your daily routine of disrupting fossil fuels, or what was going through your head?
Yeah, I'll take that one. It's part of my daily disrupt the powers that be. I got into a mood about it. Decided this is the way. No, what happened was I looked at the RepRap 3D printer, the open source 3D printer that propagated around and kind of made 3D printing popular. I looked at that and I said, that's a great solution, but it's incomplete and it's too narrow, because printing in plastic is really cool. You can do all kinds of stuff with that, and it goes far beyond, you know, what you would expect, because you can make casting cores, so you can make metal parts with a 3D printer. You can do all kinds of stuff, but it's still incomplete. So, and there's two problems with it. I've stood in front of a machine for hours on end managing it. You know, you're right back to, you're standing behind two horses pulling a plow. You're back to feudalism when you're standing in a machine. So automation is essential for people to be free from this labor trap. So getting rid of that requires automation. So they have to be automated. And the problem with things like the RepRap was that it's a cool concept, but it's still this machine that you have to manually monitor and run. So putting automation in place so that you don't have to manage the machine, that's the first step. The second step is increasing the range. And manufacturing is very clever. If you go to Shenzhen today, you can get anything made. All it takes is a little time and money. So capturing all of the essential physical processes and making them modular so that you can plug them together like Lego. So I need to drill holes in this, so I gotta have a drill press. I need to cut the end off of this square, and it's a steel part, so I gotta have a milling machine. I gotta have a lathe. I need to be able to weld stuff. I gotta have a robot. You know, all of these different processes require individual machines, so why not build, and this comes from a science fiction book actually, why not build an array of machines that plug in, sort of like the old tube technology, but each machine is a module that does some step in an industrial process. Then you have an alphabet of industrial processes that you can spell any process out with by assembling the cubes in the correct order. And obviously, you don't have to physically arrange the cubes. They can stay in the same physical arrangement. Software manages the routing through them. So now you can set up a batch of machines, and then they'll produce anything, because all of the tooling and all of the path management and all of the process order and all the other steps can be managed through software. So software still gets to eat the world, but what we've done is we've essentially made the mechanical equivalent to the Linux operating system, where you have a bunch of little utilities that do something well, and you can plug them together to do something complex. Well, this is the mechanical equivalent. You've got a bunch of simple machines that do one step, and you put them all together to do some complex thing and make complicated or sophisticated parts. So I can't claim that I thought it up. Flexible manufacturing systems, the first one was patented, I think, in 1963. So a few years even before I showed up. And but the thing is, they've been around for so long, and nobody has ever approached it from the standpoint of bringing it to affordability for ordinary people. So I want to make a kitchen appliance out of manufacturing. I want to make it something that you can set in your garage or shed out back, or in your intentional community, or in your small town. Be able to have a factory there, because then you get all those benefits. You can recycle materials, you can make all the stuff you need, and then you can change over to a digital distribution system where patterns for every imaginable thing are transported electronically rather than physically. Instead of shipping shit all over the world like we do now, let's just ship digital patterns all over the world and make them locally out of local materials.
All right, so there's a bunch of stuff I want to talk about in there. This is fascinating. But firstly, explain to the people linear versus circular economy. What's the difference? And also that amazing stat, because you're going to talk about waste in there. What's that amazing stat about how much recycling goes on and how much usability there is at the end of the circular economy? So linear versus circular economy. And then when you get to waste, recycling.
Okay. So the linear economy is the old style economy where you mine stuff out of the ground, you refine it into materials, you take the materials, make products, you sell the products to people, and then they throw them away. And so you're done with it. It's a linear push from, it's a take, make, dispose is how you do it. And that, lots of natural resources follow that path. And the circular economy, on the other hand, what you do is it's the same general process, except at the tail end of it, when you dispose it, it wraps around to the refining step, and you reprocess those materials. And obviously, if you did this as a matter of course, we do recycling as an afterthought. We throw stuff in the bin like we always have, and it gets all mixed together, and it gets crap all over it, and it's degraded and contaminated by the way we dispose of it. So we've made it very hard on ourselves to do proper recycling, and we need to fix that too. But you take all that crap that you get now from the waste system, and you have to do a lot of cleanup and a lot of reprocessing to get it into a usable state. Ideally, what you would do is intercept it at the point of disposal, and you'd have nice clean materials, and then you could put it into that circular economy where it goes around to the point at which it's no longer useful, and you dispose of it, and it's promptly reprocessed back into something useful. And two advantages to that are that the materials don't become litter, they don't end up in the harbor, and the other side is that the cost of everything you make becomes much less expensive because it's being built on top of materials that are on their third or fourth or fifth usage for the same refining cost that the materials have right now. So they cost 20% what they would now by the time they've gone through the pattern for the fifth time. The other part of it is that you look at the size of the waste problem in the world, and it is absolutely mind-boggling. There are actually a total of about 6.3 billion tons of waste every year. But that counts in a lot of like mining waste and other stuff that's really heavy and doesn't move very far. So that number is sort of distorted. If you look at just the United States and look at municipal solid waste, just household trash, it's 250 million tons of municipal solid waste in the United States. We recycle about 37% of it. The other, 36%, whatever. The remainder, 34%, because about 66% of it ends up getting buried. And out of the total, out of all 250 million tons, about 9% of it that goes into the ground is metals. And at market costs, those metals are worth, or at waste costs, those metals are worth $40 billion a year just in the United States. So if I came to you and proposed that we go into mining for lithium in the middle of Mongolia, and we were going to make $40 billion off of it, you'd jump all over it. You'd think that was a great investment. But we throw away $40 billion worth of metals in the United States, and we don't think anything of it. So it's a kind of insanity.
Yeah, the rare earth minerals, that's why a lot of that waste is terrible. $40 billion of lithium, you said, which is batteries, right? So, I mean, that's terrible.
Well, metals.
Yeah, sure. So then you come in and you say you have modular components that all fit together to make a cube, and the cube therefore can manufacture different products.
It's actually a set of cubes. So there are cubes of the same size that are built to the same. It's very much like form factor. If you remember on older computers, they all had, CD-ROM drive was a standard component. There were something like 250 different businesses were founded just on building machines to fit into the 5 1/4 inch drive bay. It was form factor leads to the ability to standardize the mechanical and electrical interface for something, and then you make anything fit. So if I built a machine to sort turnips, and every cube was one station in the turnip sorting machine, and it's open source, the benefit to that is that everything is standardized. So if I want to sort tennis balls, I can use the same vision system, the same pattern recognition, the same artificial intelligence, so whoop-de-doo. I can use all the same essential parts to it. It was designed to sort turnips, but I can make it sort tennis balls. And then somebody else might come along and say, hey, I can fork that project and use it to grade eggs, because grading eggs and sorting tennis balls isn't radically different. There are some different details. You will have to make some modifications. But in general, the system, you solve a problem once and then it propagates to all of the spaces where that problem is similar. And so the advantage in that is that your development costs up front are lower. And the waste problem that we started talking about is endemic everywhere. Every big city has a lot of waste. Well, they don't have any waste. Those are raw materials. Those are semi-refined materials that somebody in the 1940s would have just gone insane over. It's like, I can't believe you're throwing that plastic container away. That thing's amazing. And today we just huck it in the trash because we've gotten immune to the idea that it has value. I don't need it anymore, so it doesn't have value. But it's the same petrochemicals that were very expensively extracted out of the ground and transported all over the world to get to where they were. One of the things that people don't really take into account, I don't believe in profit, and that sounds fairly heretical in the modern world. People think I'm a wild-eyed heretic. But if you look at the amount of environmental damage that is done by the petroleum industry and the shipping industry every year, the UN estimates that it's about $6.6 trillion. So again, out of a $100 trillion economy, $6 trillion of it is just damage to the environment. And another $2.5 trillion is remediation, where river systems take chemical poisons apart and so forth, and actually, render them neutral. So that's $8 trillion, or about 12% of the world's economy. It's destruction. And so if you factored that back into the products that are produced, do we have a net average of 12%? I don't think so. If you count mining and all the other stuff where they're relatively low margin businesses, um, there are no profitable businesses. Somebody's just not paying their bill, is what it really boils down to. Ultimately, that's what it ends up as.
Yeah, yeah. Well, it's reflected in the interest rates. Why do you think everyone has to? Why do they have to go to 0% rates? Because if you raise rates to 5%, a majority of the global businesses would go out of business tomorrow. I'm telling you, they have to go to negative to keep everything afloat because there's no profitability. You're completely right.
The margin's not real.
The
There
subtext
are no
of
margins anymore.
that's the fundamental joke about this whole transhumanist show is that people say why you call it detonation. Well, because that's the underlying structure of how this whole mess is perpetuating itself. It's through debt-based economy, debt-based capitalism, and a debt-based system built on crazy, interest rate policies, and that's how this whole thing just keeps on turning. And until that is worked out, that's the subtext of the detonation thing. And people say, oh, this, you've got to put it all together. That's how it works. But yeah, no, this is so. You said so. Eventually, you go to you go to a digital transfer system. Are you worried about? Because you were inspired, let's say, by 3D printers, right? And are you worried about security concerns within that landscape? People 3D printing guns or 3D printing or printing. Are you worried about security concerns, or is there safeguards and mechanisms built into the cube spawn?
I really have a kind of a low regard for. If your motivation is in a world of plenty, if everybody is capable of producing what they need, the likelihood that people are mostly motivated to become to engage in terrorism or to engage in activities like robbing people when you have an abundance of wealth yourself doesn't really make a lot of sense. It's a pathological behavior. So we leave it to billionaires and bearded guys. Oh, wait a minute. But we leave it to people who are a little off to worry about that. And the 3D printed gun thing, I think that's hilarious because that's actually local here to where I live. I live in this San Antonio, Austin corridor. So, and the guy in Austin is the guy who did the 3D printed gun. And I think it's ridiculous because there are much better ways to make a gun. I can go on Craigslist and find a metal cutting milling machine. I can find them all day long. And with that, I can make any machine imaginable, any mechanical machine, which means I could make a machine gun if I wanted to of any caliber. And I could also make the machines to make ammunition for it. I mean, there is no limit to what I can do with that milling machine. Nobody's worried about them as security. Everybody's worried about 3D printers, though, that I'm going to print a single shot gun that's probably going to blow up and take the side of my face off. That's a danger. What that is a focus on the wrong thing. Some idiot can definitely do something bad. For example, I will submit that there's a guy in Scotland who's putting together a thing called the Chemputer, and basically what it is it's a bunch of dosing pumps, and he can do chemistry inside of the machine, so he can print pharmaceuticals. Like you can add some chemicals into it and print aspirin. So you could also presumably print explosives. You could also presumably print toxins. I mean, but that technology is coming because the idea of having desktop pharmaceuticals means that people don't have to spend a lot of money to get the things they need. And so all of a sudden this artificial barrier to big pharma goes away. That's a technology, a disruptive technology that's in motion that will definitely happen. There's no likelihood that it won't. 3D printers, high quality 3D printers, you can print little reaction chambers, which means you can make any substance imaginable. Those are real technologies that are out there today. Somebody with a little bit of chemical knowledge and a high-end 3D printer can make a chemical plant the size of a washing machine and make anything they want. So security is primarily a response to people reacting to deprivation. If you remove the deprivation, you remove most of the motivation for people to act crazy. You can't completely eliminate it because some people are crazy. That's just the way the game is played. But if everyone has access to their basic needs are covered and they have access to opportunity to improve their lot in life, there will be a lot less people pissing their time away on doing something destructive and stupid. I don't think it'll ever completely go away. Some people are just nuts. That's the way it goes.
Yeah.
But so, and to answer your question, are there safeguards? There are none. And there are none for the reason that I think those are counterproductive, and I think they're only brought about artificially. If I wanted to do something terrible, I could. I have the knowledge, but I have no desire to, and I have no motivation to, because doing good stuff is much more likely to bring me to my goals than doing something bad and destructive. And I think that all rational people will think that way, and irrational people are, by this definition, not in the same category.
That's a really good point. It makes a lot of sense. Because I guess like in Australia, the idea is with 3D printing, the security concerns are we don't have guns. We have laws against guns, and not everyone knows how to use a milling machine. So therefore, blocking that code, you block the guns, and you block unregulated guns, because every single gun in this country is it's got a number and it's supposed to be tracked, and if you don't, you get a fine and all this sort of stuff. It's a little different to America, but there's a few countries out there in the world, in Europe as well. Canada, I think, has an anti-gun law. America is an exception, actually, in the world, in gun freedom it has, and that's whole nother debate, whatever. But
right.
Well, it is. It's a whole nother thing. It's the Constitution. It's freedom. It's but anyway.
It's propaganda. It's all that stuff.
Yeah. It's a whole other point. But this is the thing. So it's as simple in this country as somebody has a 3D printer. You block the code. The code can't go through. There's no unregulated guns. That's the end. And like you say. Yeah, I'm sure I'm here in an industrial area. I'm sure that there's people with milling machines around the area. People who do recycling down here. People who do manufacturing over here. I'm sure that they could probably do the same thing, but I highly doubt that they are. But the normal people at home, I myself didn't even know you needed a milling machine. I don't have that engineering capacity or knowledge or whatever, and nor do I desire to do it because I'm too lazy to even get involved with that arena. But I have no desire. I think the argument is the kids at home, the dare, I dare you, or the guy who prints a gun just as a once-off to kill his wife or whatever,
So I contend that same kid could go and throw a brick off a bridge at a vehicle. The idea that you can make the universe a safe place is fallacious at its core. And idle youth, why are they idle? That seems like a different kind of a problem. There are many things to do in this world. And having people sitting around daring each other to do something stupid is a societal problem. It's a different kind of a problem, but banning, pointy sticks is probably not going to address that problem, because those kids could still find a pointy stick somewhere and poke their eye out. Or there is not the world will never be a safe place.
Okay, putting security concerns aside, what would you see? If people adopted this on a local level, if a community adopted this, if local community groups adopted this, they started making these machines, what do you think the uses are primarily? What would you expect the first couple of products to be printed as? Clothes, shoes and clothes, and like plastic materials, bowls, community garden implements. What do you expect the products, the main product base would be?
Well, the intent is that phase one is these prototype machines. Phase two is support equipment for these prototype machines. Still fairly boring, not really community oriented. Phase three is where you start to get into producing things for community agriculture, putting together systems for high density agriculture like the pumps and fittings and all the other stuff that's necessary for aquaponics, where you take fish and use those fishes waste products to feed plants, and the plants clean the water, it goes back to the fish. You have this kind of closed loop agricultural production at about 100 times the density of dirt farming. That's a place where this shines because it gives you access to all the technical parts that are necessary to build a relatively complex system. It's a step up from dirt farming. Dirt farming is great, but it's starting to hit its limits in terms of the density of production is too low, especially in highly urbanized areas. So people are starting to go to the to aquaponics warehouses where they can grow, 100 acres worth of food in a city block. And aquaponics is a clear and obvious application for this. You get two benefits by having your own micro factory. You can produce the technical parts to construct the system to begin with, and you can produce all of your own spares locally out of waste materials. So the thing's not going to break down because you can produce spare parts as needed immediately. And in fact, if you mix a little AI in there and several generations of revisions, probably the system will anticipate the failing part and produce it before it happens. So automating maintenance to me is an enormous part of this, because then the machines can act autonomously to produce a spare. Well, this part has had 50 cycles on it and they fail at 70. Let's produce a part and have it in inventory. And then as soon as it fails, it gets replaced because there's already one on hand. And after you run fairly complex, large systems, all of the failure points become obvious, and AI can readily address that problem by anticipating failures and also implementing the repair itself. The idea with this is that most of the maintenance in these machines will be done under automation, and they'll be pretty stupid at first, but they will get smarter and smarter every week. And it won't take but a few years until the machines essentially will run itself, and it can't break down.
Would it be a central AI, or would it be a diversity of AIs, or a mix?
I think it'd be a mix, especially during the development phase, where you would collect data from a lot of systems, run it through fairly high density computing to get the answers. But then after you had brooded the bigger problems out of the way, smaller, local, and transfer learning, because if you create a model at the central location that understands how to resolve a problem, then you can do transfer learning with that model on local problems. And image analysis is another thing that some of these systems, I talk about this as if it's hypothetical, but I have a significant portion of a prototype built for the manufacturing side. And I also have a buddy who made some money in cryptos and has built an enormous greenhouse. It's a 6,000 square foot basement that's going to grow mushrooms and fish, and 3,000 square feet of greenhouse that'll be growing the plants that the fish will feed. The mushrooms produce carbon dioxide that helps the plants. The fish produce a lot of humidity in the environment that helps the mushrooms. So there's a lot of synergistic loops inside of this thing. And this CubeSpawn system makes all the technical parts for these systems. And the idea is to make this a replicable greenhouse where all of the digital blueprints for all of the parts that are necessary to bring it together would be something you could just download. So one day you don't have much, and the next day you have all of the necessary information to build a community greenhouse from scratch. And all you got to do is feed in, soda bottles and broken toys.
Wow, that's
and that is the goal.
You ever been called
that's the goal.
One of the coolest people I ever met?
I have. I've been accused of being all sorts of things. Mostly a madman because I'm living off the edge of reality a little bit. But I
Yeah,
think all these
well,
things are possible.
yeah, these things are possible, and don't know how much you know about Terrence McKenna, but I enjoy that guy's theories a lot, and it takes the people who are just a little bit off the edge of reality in order to envision disruptive technologies of this capacity. But yeah,
I have to I have to give credit to science fiction authors that I read when I was a teenager. All of this stuff had been hammered through in the 60s. I mean, every bit of this had been thought of. Somebody put a clip on Facebook a few minutes ago about somebody ordering a part online. Film was created in 1956. It was a long time before that was remotely possible. But someone had already thought the process through. They just didn't have the means to implement it at that point. And that's what I'm doing is I'm borrowing from all these brilliant science fiction writers who they thought of a cool solution. They wrote about it. It was totally impossible in the world they lived in, but that didn't stop them. And it's not impossible now because IoT, the rise of automation, the rise of AI, all of these tools that we have, cheap instrumentation. I mean, there's no excuse not to do this. The parts for it are everywhere. They're pervasive, and who's going to do this? General Motors going to do it for you? Not a chance. You're going to have to do it yourself. So I'm trying to get enough of a framework out there to get the ball rolling. And a shameless plug, I have a Patreon because
yeah. Check it out,
haircuts and
people.
oatmeal.
I'll leave links and all that. I mean, my broadcast capacity isn't that high, but we have really high IQ. Like we have really high caliber audience here at Detonation. The viewers are very, very smart, very well connected people. Transhumanists and really, really engaged, intelligent audience. So that's kind of the niche. It's a high IQ, highly engaged, well connected, small audience, but those guys can take you a long way if I'll leave the link in the description. People need to check out CubeSpawn and check out Patreon and get onto it because that's fascinating.
Well, if I can crowdsource the funding for this and get a basic template in circulation, my expectation is that if this succeeds, I shouldn't be able to recognize it in 5 years because I expect it to evolve far faster than any single individual could hope to keep up with. But that would be a sign of success. If it runs away from me, I succeeded because I've turned it loose.
Yeah, it's kind of. I was kind of leaving this one till the end, or whatever. I don't know how long we're going to talk, but I was just kind of holding on to this one because, Nick Bostrom or whoever they talk about in the end of time, we sort of become self-replicating robots, and you send these self-replicating robots out into the universe. They build a factory. And then they go, and then they build another one, and they keep going all the way across the universe, and that's kind of the end of the story. You're kind of doing the same thing here, right? But it's sort of like that.
There's no reason to believe that this doesn't lead to that. So the clanking replicator, that's sort of the beginning of all of this. And that's, now of course I'm going to draw a blank on stuff that I know well, but it falls out of my head when I'm having this kind of a conversation. A whole bunch of different people have kind of gone through this von Neumann machines, and that's what that is the self-replicating factory. Once you reach the threshold, obviously I kind of have this feeling that the phase 1 machines, my little prototypes, you got to buy motors, you got to buy bearings, you got to buy all kinds of stuff because you can't make it. Phase 2, you're in the same boat, but a little bit less because about 80% of the parts for phase 2 can be built on the machines created in phase 1. So the other thing with this is, like software, these machines make their own upgrades. They make their own. You design within the limits of the system to get the desired result, and it's like the recycling portion of this. If you build a system that contains automated machines that are capable of manufacturing, and you have a control architecture that's capable of running all of those machines, well, you've created everything you need for a sophisticated recycling system. Because what do you got? You got a whole bunch of sorting machines, you got a whole bunch of classification, and all the types of machines are the same, and you've created a control framework that'll run manufacturing machines, so there's no reason why it wouldn't run recycling machines. And now you've got materials. So you've solved two giant problems with one effort, and now you have lots of materials, lots of fabrication, and the next thing is obviously energy. And if you have those things, you have the three pillars of civilization. You have energy, materials, and fabrication. That creates all the technology we have. So you've solved this fundamental problem, and now that leads back to, how do you solve the shipping problem? Well, don't ship. Ship the 15% of stuff you actually need to add as virgin materials, and leave the 85% out that's already in the community where it's needed, and just recirculate that stuff. A couple of generations of that where you design for recycling. You get rid of stupid products that you can't extract the materials out of, because why would you do that? You can use those materials again. That way your trash starts to have more value, and the cost of goods go down. Energy is free, it's falling out of the sky. We use 15 terawatts of energy as a civilization around the world, and grimly enough, we use about 80% of that is from chemical sources. It should all be solar, because 89,000 terawatts of energy falls on the earth every year from the sun. We don't have an energy problem. We just think we do. And if we take that energy and apply it to fabrication with recycled materials, we can build, whatever kind of utopia people want to dream up, and do it in a way that has zero impact. It's all closed loop. You're not ejecting crap into the atmosphere and into the seas and onto the land on a continuous basis. You've resolved that problem, and then what are you going to build? Well, let's build a high-speed rail transportation system and put them in big hexagonal grids all over the planet. How you can go anywhere quick, and you don't have to run over animals on your way there, or deal with rainstorms. Like I said, all these problems can be solved. They are solved. They've been solved in science fiction for decades. We just need to apply them to the world around us and quit acting like, I like to say that this is what civilization would look like if it were run by monkeys. Just look out the window. And as long as we're going to keep competing with each other instead of solving fundamental problems. I mean, once you solve fundamental problems, people say, well, there'll be no challenge left. Oh, poor Patuki. That's nonsense. There's lots of challenges left. We haven't even begun to scratch the surface of getting off of this planet, inhabiting Mars or the moon or orbit or whatever we eventually decide we're going to do. And we have a very complex world coming up, not only climate change as a threat and a challenge. I think climate change could be completely solved if you were to circularize the economy and quit ejecting crap, because then you could we have a lot of surplus energy, right? We have 89,000 megawatts. We're only using 15 terawatts. I mean, we're only using 15 terawatts in our society. That means we got somewhere in the vicinity of 1,000 times as much accessible energy as we're using right now. You're telling me we can't fix the atmosphere in short order with access to that kind of energy? We have mind-boggling amounts of energy available to us. We just have to apply it to capturing carbon. Turn it into carbon fiber. Do something useful with it.
Yeah.
Get it out of the atmosphere. Now you don't have a warming problem anymore.
Yep. David Billy, he's out there in the USTP climate advisor, and that's what he's doing with his carbon capture schemes. It's incredibly interesting, and yeah, like human civilization up until now, until recently, has been solar powered. When you really think about it, it's been solar powered through agriculture, and then powered, water, hydro powered. I don't know. We need water to survive, but basically being solar powered up until the 50s, or up until basically coal and fossil fuels came onto the scene. So it's only really recently a new conception of this alternative energy scheme, and the alternative energy scheme is actually fossil fuels. That's the new one on the block, and it's a dirty yucky transition, and hopefully it's something that we can fade out real quick, because it's new, it's dirty, it's yucky, it's inefficient. Yeah,
Well, it's made an amazing change in the human condition,
oh yeah.
but the cost is too high. And actually, if you look at about 1850 is the transition point, because about 1849 is when the first steam-powered farming machinery was released. It was too expensive for anybody normal to afford. You had to be a huge co-op or a really rich guy or something to afford the new steam-powered equipment. But if you look at the world's population has gone up roughly 7x since 1850 in the last 170 years. It's about 7x increase in population, but it's a what is it, 34x per capita energy consumption. That means that as a society we have 7 times as many people, but we have 223 times the impact. yeah. That's
One's vertical and one's almost vertical. It's kind of messed up.
Yeah, well, we have this tremendous amount of increase. So you are literally, in an energy standpoint, you're literally 30 times as rich as an ancestor just 170 years ago. We have access to 130 or 223 times as much energy across a society only 7 times as large. And you know, when people talk about what's impossible and they don't have an awareness of what has already been done, it's a little bit disheartening, because we are capable of flipping this problem on its head almost instantly. And there's all this doom and gloom and fear and terror in the world about climate change. Well, get off your ass and fix it, because we have the tools to fix it. We don't need to have this problem. We need to implement the solutions to correct this problem. I've been talking to a group in the Philippines, and they have a problem with some rebels. And they have the reason that they're rebels is because they're economically disadvantaged, and they have little hope in their community. So they took up arms at one point, and now I think they're in negotiations. But the point is if the goal is to build them a resource-based economy, the RBE keyword, build them a self-sufficient village. And the people who are working on that have been talking to me about using my machines in the scheme. And I'd love to see it happen, because that would be a way of validating the idea that if you produce an environment for people in which they have all of their needs met and are secure, they have no reason to oppose the government.
How come you're not at the United Nations? Why aren't I reading about you being at the UN?
I'm not that guy. I don't know. I've been a closet tinkerer for a long time. I'm happier in the shop than I am out moving and shaking and rubbing elbows with people. Social introversion, I believe, is what is the answer to your question.
Yeah, well,
I like to sit around and think about stuff.
Because they're the people who want solutions to this. And Greta Thunberg said, we have solutions, and I'm not sure if she's talking about your solution, but she's saying that they have solutions, especially the United Nations, and a global organizational policy can be implemented to enact solutions to, let's say, climate change, right? But
right.
We got solutions right here.
Well,
I mean, yeah, it's an entrenched oligarchy that's.
I think that the grassroots solution has a much higher likelihood of actually resolving the problem. All the top-down stuff, you go into any country where the government isn't well-liked or well-trusted, and you have a policy, no matter how well-motivated that policy is, getting implementation on the ground is very difficult when people don't respect the government. All you're going to get is corruption. You're going to get the funds going and doing everything except what they're supposed to. Far better to make people's lives better directly. If they can make their lives better directly with the solution that you apply, what you're doing is you're shaping the answer. If you want a particular outcome, then you need to backtrace from that outcome and implement a solution that dictates that as an outcome. So that's what this project is about. is that if you use this project, you end up doing this thing. You collect waste and you turn it into goods, and you generate power or create power generation systems, and all of these things happen. And when you do that, the secondary consequences of every one of those events is to push the world away from where it's at and towards a solution that includes not destroying the environment, not oppressing each other, not trying to leverage, some money over another group of people to get them to do what you want. Do it yourself. You can do it yourself. You remove the incentive. You remove the incentive for a lot of the things that drive the world today because you provide a direct solution that is tangible.
Are you friends with Peter Joseph, or what, the late Peter Joseph, or are familiar with the Zeitgeist movement? Either ones of these?
I am familiar with the Zeitgeist movement and the Venus Project, and I like the tenets of resource-based economy from Jacques Fresco. I think all of those are good things.
That's the guy as well. That's the other one.
Yeah, but I think those are all wonderful things. But I think that they're a little too intangible, and they've not seen the kind of adoption that they need. Like, if you take and look at the Venus Project, it's got like 2 or 3 million followers, which is great, except it isn't great because there's 7 billion people that need a solution. So, and it's been around for a long time, and it's gotten popular. It's almost 20 years since it broke out and became widely known, and you got 2 million followers out of 7 billion people. And as far as I know, there is not one TVM. The Venus Project, there's not one TVM city, or even plans to build one, because it's too big. The starting point that it begins at is in unobtainium. It's not something you can get your head around or your hands on. So that's another reason why this is small scale, little benchtop scale machines are the size of a 3D printer, because they aren't intimidating. You can actually build these damn things, or you could have a technical friend build them for you. And the idea is to get, what I want to do is build about 200 systems or whatever, and get them distributed around. When they're each going to build 10 systems, so now, you have 10,000. And from there, I don't really need to be involved, because it's people doing it for themselves, for their own motivation. They want to make their lives better. This is a way to do it. They have plenty of incentive, and it's small enough that you can start. These systems are still going to be expensive. It's going to cost about $50,000 to build in the United States. It costs about $50K to build one of these prototypes. I've actually spent about $80,000 in 5 years getting this together, and I've got the cooperation of somebody who gave me a machine shop inside of their business, and they tear down industrial machines, so I've got free access to buttloads of materials that would cost me a lot of money. I went to a research and development institute here that they told me it cost me $3 million to build this prototype. I've done it for less than 80 grand. It's taken 5 years. Do it yourself. You can do yourself things which are impossible in the financial framework. The financial framework is a barrier. It's not there for your benefit. It's there to stand in your way. That's mostly what it does. It's a club with gatekeepers that keeps us, the riffraff, out. That's what it's for. If you don't have a big bank account, you don't get to play.
Yeah, that's true. I mean, we're sitting here in Singapore or somewhere, I don't know, but we're here in Singapore, and it's the truth. That's what it comes down to. It's if you're not in alfalfa, you're not in anything. So yeah, it makes sense. If you're not visiting Bohemian Grove, you're out, and we're all out, because this is a disruptive technology that is big. Okay, paperclip maximizer theorem. Hit me. You're familiar with the paperclip maximizer theorem, right?
I'm not familiar with it.
Okay, so the basic premise of the paperclip maximizer is it's a parameters idea. It's this idea that somebody tells an AI machine, or a machine kind of like yours that's a manufacturing machine, and it says maximize the amount of paper clips that you produce over X, like ever. And And what it does is it goes, okay, that's fine. I'll produce the maximum amount of paper clips, but it starts to eat up everything in its path. It gobbles up the world. It gobbles up the energy of the sun, and it doesn't have any ethical concerns, any ethical parameters. All it does is just gobble the whole universe up, because that's what it was programmed to do, to churn out paper clips. And it's just this single-minded AI. It does no limits. It just does everything it can to churn out paper clips. Is there a problem there? I mean, it's open source material. I asked you about security. Forget about that. You're gonna have a diversity of AIs and or a single learning AI, but you said diversity. So what about people programming it to produce one thing? Let's say shoes, and it goes nuts. Is that a problem, or it's not a problem?
Well, it's a hypothetical problem, but I think if you put in practical constraints, who needs all those shoes? And if you have local manufacturing and you sort of diffuse the shipping industry so that it only ships, let's say the shipping industry of today, which has somewhere in the vicinity of 20,000 ships on the seas, let's say you dropped it to 15% its current size, and you turn this shoe manufacturing maniac loose. Where are those shoes going to go? The local market can't absorb them, and there isn't a shipping infrastructure to get them everywhere they need to be. So it's a interesting academic idea, but I don't think that there's any practicality to it. And also, if you're working on local level materials extraction, where did the materials for all those shoes? It's really sort of constrained by the fact that you don't really ship anything if you don't have to.
So your machine, because your machine isn't working at the molecular level, it's only working off the materials that you can really input, which is the waste side. You can input new materials as well, but that would defeat the purpose, sort of. But yeah, the waste side, it's kind of constrained by the fact that you need inputs, yeah?
Right. Well, the local circle is of so many tons of material, and that circular. There's certainly an ability to overutilize one material over others and break the system locally. You could do that, but I don't think you would. I mean, because again, these machines aren't centrally controlled or centrally owned, so there is no one controlling them that has an incentive to do wrong with them. It's only the other thing is, I think that it would be worthwhile, although anytime you start getting off into the weeds with this stuff, its level of implementation becomes questionable. But local ownership, basically everybody who's a customer of that system should have a fractional share in it. That way you've essentially defeated the concentration of wealth, which gets back to what I was talking about in terms of how does this address political corruption. Corruption requires money. Concentrations of wealth require the centralization of industry. This decentralizes industry, and it's hard to buy corruption with the kinds of outputs you're going to get from small localized systems, which means that a lot of political corruption money funding goes away because you can no longer own a giant international shipping line, or all of them, like some of these guys own, thousands of ships. Well, there would be no incentive to do that because you're shipping. The diversity of sources, and shipping should be, of course, shorter than it is now. You're not going to ship trash from the United States by truck to California and load it on a container ship to move to China to recycle it to make products that end up going to Botswana again. That doesn't make any economic sense. We only do it because we are not paying that $6 trillion a year in environmental destruction. That's the only reason, is that by not paying the bill, you can make your balance sheet lie to you and tell you what you want to hear.
Yeah.
This is a profitable idea. It's not. It's a stupid idea. But that doesn't stop anyone. They do it because they can bury the fallacy of it in environmental damage. And you can just hide. It's like, where do you bury the bodies? Well, that's where the bodies are buried. Environmental damage is where the bodies are going.
Yeah, there's a technical term for that. I forgot what it is now, but it's not outsourcing. It's the overflow of environmental destruction is, it's not outcosting either. There's
Externalities.
externalities. That's the one. Yeah,
Yeah,
it's
yeah.
all an externality
Yeah,
cost. Yeah, it's off
You see,
balance sheet.
any cost you can externalize, basically, you're just not paying that bill.
Yeah,
It's easy.
it's off balance sheet, which brings me to another question. And, you know, talking about the diffusion of political power, now this is interesting because transhumanists, and this is a really good debate, talking point in the last show. If we're at 128 or something now, I don't know, go to 127 with the other ones. But we were talking, because this was a different idea, but most usually transhumanists talk about this decreasing price point of technologies following along this sort of Moore law curve, and you know, technologies become more cheaper and more available and more widely spread amongst communities. The other gentleman who was just on, he said some of those theories are cherry picked. You know, the technologies that transhumanists use to talk about that is cherry picked, mobile phones and other things. He said that's not always correct. But yours, let's talk about yours. So it went from a hypothetical $3 million to immediately to $80,000. You're projecting $50,000 for the first prototype. That's a big price decrease right there. You think by the third, fourth, fifth prototype, where are we looking at a price decrease point? Because if I'm a warlord in my community and now I have one of these machines and I'm going to be the big powerful guy that can produce the aquaponics infrastructure, what's the price competition of the guy next door?
I haven't met the guy next door. So.
No, but where's the price point going of these machines over time?
Zero marginal cost. The idea is that essentially the cost of goods will fall to materials and energy cost. And if you're generating your own electricity and you're building from recycled goods, that is an asymptotically decreasing price that eventually, it never reaches zero, but it isn't much. Because I have some plastic article, and and this plastic article has some fixed cost because of its petroleum extraction cost and its transportation costs and whatever percentage of that they actually had to pay. Not all of it, but a lot of it. So it starts off there, and then it goes downhill, because every time I reuse this plastic, we presume if aluminum is a reasonable model, it costs almost 90% less to recycle aluminum than it costs to extract the bauxite the first time, because you've already got a refined material. All you have to do is melt it down and form it into something else. So the cost of goods should fall to their material costs, which for many things is quite low. So the warlord with the aquaponics system, the second aquaponics system should be 30, 60% of what the first one was, because again, it's recycled materials and established systems to take that waste material and turn it into, Africa's got a terrible plastics problem. I just talked to somebody in Sierra Leone a couple of days ago, and they sent me a bunch of pictures of the area around where they live, and it's just a disaster. Plastic waste everywhere. Unfortunately, that's low quality plastic waste that's been degraded by sunlight and all that stuff, so it's not prime material. But if you gave people an incentive to pick it up, and in turn you could give some societal benefit out of whatever you made out of it, I think making it go away would be the best thing. But there are no viable alternatives for a lot of plastics at this point. There will be, and bioplastic, like.
What type of companies, what company types or company specifics or future companies do you project that are going to be okay? So in the recycling, recycling, you want good plastic, for example, right? You can't really go to New York and what do they do? Garbology or whatever it is, where they dig down for 50 years.
Right.
You can't. Okay, question one. Could we actually use that garbage that's been sitting in there for 50 years? Is any of that useful? And maybe is the lower stuff more useful than the higher stuff? We'll start with that.
Okay. I think the answer is yes, and the reason I think that is that I think mining the landfills is maybe phase 2 or 3 of implementing localized manufacturing in a community, because three things again come together: energy production. So, are you familiar at all with gasifiers?
Acid
Um,
fires?
no, gasifier.
Oh, no.
Gasifiers were used in Europe during World War II. The Allied forces bombed the petroleum production infrastructure out of existence. So the Germans uh, reverted back to a different form of fuel production, which was to burn wood in an enclosed container, capture the vapors that come off of that, and run it through a regular gasoline engine.
Oh,
And it's
potatoes as well, right?
pardon?
Did they use potatoes as well?
Well, they used potatoes for the production of alcohol, which was then used as fuel, but that's
Right.
a different process. Now, this is
Okay.
actually, if you've ever burned, I don't know if this is a thing you do in Brisbane, but if you've ever burned leaves and burned a pile of leaves, and you get, sometimes the fire won't really be burning very well, and there'll be this really heavy white smoke rolling up off of it. That's actually flammable gas, and it will occasionally ignite, and you'll get kind of a big flare off of your when you're burning wood waste. And what the gasifier does is it deliberately causes that to occur on an ongoing basis. The idea is that you burn stuff at very high temperature, but a relatively low, small volume fire, and the fuel goes through, a lot of it gets vaporized, and then you filter that, and you end up with, it's essentially the same as propane in its chemical composition, but it's arranged differently because it's water vapor, hydrogen, and a whole bunch of other gases that aren't combined, but the molecular weights are similar to as if it were propane. And that can go directly into a gasoline engine and burn. It produces about 70% of the equivalent brisance of gasoline. So you lose some horsepower on the engine, but it burns very clean. The exhaust emits very little smoke. So gasification can also be applied to plastic and other types of waste. And the other part of it is if you take the gases that are produced during the process and you run them over catalytic plates, you can essentially, you're mining the gas. You can mine the gas and recombine what's in it into waxes, oils, petroleum. You can create lubricating oils, all sorts of stuff from wood smoke. So, and when you burn plastic, and now this is something, I know somebody indirectly who's a PhD, worked for the UN in, I think it was Iraq, and what they were doing was they were taking chemical weapons and making them safe, making the residue safe. What they were doing is burning it in the gasifier. In essence, they were vaporizing at high temperature all the constituent elements of the, whatever the dangerous material was, sarin gas or whatever it was, breaking it down and recombining it over catalytic plates back into benign materials. So gasification can be used for that purpose, and you can, I'm building a gasifier to run my pickup truck on with wood. This is a popular hobby amongst ruralites in the United States. So it's not popular in the sense that there are very many units running, and in fact, you wouldn't want a large part of your transportation system to be running on wood waste because you'd denude the entire planet in a week. So it's not a great idea from the standpoint of transportation, but it is a great idea from the standpoint of disposing of plastic waste, because you can make it so that it does not emit anything toxic or harmful. And consume that plastic waste and turn it into energy, which can then be used to run the machines that fabricate clean plastic back into products people can use. So all the plastic that doesn't make the cut as being useful for recycling can then be used as fuel instead. And so you get rid of it, at least you got it out of circulation, and all that's released into the atmosphere is all the usual products you would expect from burning wood, which isn't great all the time, but it's far better than any kind of toxic emissions, which you get from burning plastic in the open, which is to be discouraged.
Yeah, that makes sense. The only reason I said potatoes is because You know, for example, when Werner von Braun, they were trying to build those rockets. I knew that at one point in the war they ran out of fuel essentially, and they diverted a huge amount of those potato fuel to
Right,
launch the
alcohol
rockets.
from
Yeah.
right, yeah, alcohol and oxygen, and but
Yeah, and
for
it
for
caused a bit of a famine, or it caused a bit of starvation, but yeah, they launched the rockets with it, so that's kind of interesting. And I'm a fan of
right.
rockets. Um,
Right. Well, 60% of the road vehicles and farming equipment in Europe was running on these wood gasifiers at the peak of the war.
okay,
So,
wow,
and that's something you could, Google, and it's an interesting story because the technology really dates to 1834. I started gasifying coal to run streetlights, and then throughout the 1800s, it was used, sporadically here and there to gasification for running various things and producing fuel for various purposes. But then, as soon as gasoline was introduced, gasifiers immediately fell out of favor
yeah,
because it was a much more difficult process. And even in the 1940s, sitting around in your gasification running vehicle, the exhaust would asphyxiate you because there was a lot of carbon monoxide and a lot of other stuff. So, obviously, in the modern versions of them, there's instrumentation to tell you if you have a problem and if your exhaust gases are out of spec.
So yeah, so let's finish up with aquaponics because you know you're going to be producing these aquaponics products, right? So you're gonna assist the aquaponic industry at the start. That's correct? Yeah.
That is one of the main goals, is to be able to produce high density food production. Um, I consider that to be, I've recently sort of divided all these ideas up, and that's sort of phase 5. So,
All right, let's go through the
phase,
phases again. Let's go. So phase 1 is, and let's go how many phases
just
there
as,
are. I mean, up to Nick Bostrom's at the end.
well, well, if we go to Nick Bostrom, we have to add phase 6, but phase one is just getting the prototypes operational.
And that's
Phase
where we are
2,
now, yeah?
that's where we are now.
All right.
And then phase 2 is to add all the accessory machinery in that's necessary. Like, the machines, of course, are small scale. They don't have very big work envelopes, so you're going to have to cut down materials, which means that you need to put together a plasma cutter, a plasma or laser cutter, a panel saw, and potentially a water jet. Those are all external machines that have to be built to support this. That's phase 2. Phase 3,
Eliminate
we get.
those.
Sorry.
So phase
Well,
3
phase
would be
3
eliminate these externalities, yeah?
Well, the external machines are really just machines that, at the 1.2 meter scale, that can be bootstrapped off of the 600 millimeter base machines.
Okay.
So, and then they process sheet stock and rod and other very basic industrial materials. They will pre-process that stuff so that the much smaller machines can manufacture parts from them. And then obviously, scaling up and down is something that isn't really in the phasing thing, because the idea with the phases is that we're going to progress through these phases to get to a point where we can get to Nick Bostrom, phase 6, where the machines can totally make all of their own parts. But back to phase 2 is a few external machines to process materials. Phase 3 is mobile units, so that the machines can start to fetch and carry and deliver. So mobile platforms, and they also bring in the ability then to remotely control. So phase 3 is alongside of those mobile units are the recycling and power systems. So phase 3 gets you to where you can now extract materials, generate power, and manipulate the environment beyond the machines with mobile units. Phase 4 is where you start doing community building with aquaponics, agricultural robots, and all this essential stuff to support human life outside of these machines. So now you've made this inclusive of. So you have to get through those first phases to get this system so that you can bring it into a community, get it up in operational state, and then start to apply it to improving people's standard of living. That's phase 4. Phase 4 is the aquaponics and the gardening and all the other bits of it. Phase 5 is transportation. The idea is that if you are capable of building all of these components, then there is no reason why adjoining communities can't each pitch in on putting together a small-scale, high-speed rail line between the two. And now you have an actual civilization again, bootstrapped from this original phase of machines. And then our hypothetical phase 6 is where the overall system is capable of deriving everything necessary to recreate itself from that environment.
Yeah, it is much better. It's much more. Brett Nally, he came on the show and he's met Jacques Fresco living out there in the jungle of Florida somewhere. I understand the frustrations of Jacques Fresco, and I understand what you mean. But yeah, these are grandiose ideas, the grandiose schemes. I mean, from phase 1 to phase 4, phase 4 is where it gets critical for people. You're talking. You've hit all the right. You've hit all the right points. You've got demand. It's problems. There's a lot of problem solving. Integrate like the integration and the mechanisms that have been built in that, because I can see on both sides there's a lack of imagination, because like you said before, it's kind of interesting that you want to make these machines that they will outpace your own imagination, that these communities and people will come up with new ways to manipulate them and change them and characterize them and new ideas, and I can't imagine
they'll
where
apply
they
them in ways I can't conceive of.
Yeah, so that phase 4 is really it's phase 4.1 or 4.A or whatever, because that could go a really long way really quickly, because if there's solutions, if it starts devising solutions to untold, unknown needs out there in the world. I mean, the world's a big place, full of lots of people. Let's just talk about phase 4 really quickly, because do you see it hitting the? Do you see this is something really smashing its way into a developed world and just proliferating across the developed world really quickly, with the access to internet, and even though that's sort of going to be sorted out soon, the whole internet crisis, but do you see it proliferating itself across the developed world really quickly, or do you see it smashing its way through the undeveloped world, coming into these community groups to sort out poverty problems and community problems in the undeveloped world or third world or whatever it is, underdeveloped, whatever they use? Or a mix, or do you see it? What do you see? What do you see that's so exciting?
Well, as it stands, getting through the phase 1, getting a functioning prototype, it then opens the door to corporate interest. Now, this is a secret. Don't tell anyone. But if corporations were to adopt this, it's not necessarily in the long-term interest of corporations to create an independent distributed manufacturing system, but there are numerous vertical applications that will be attractive to them, because now you can make your product, you can bootstrap the distribution of your product. So getting that phase 1, completing phase 1 and getting a functioning operable system, there's literally, I did the analysis on the US market. And the U.S. market, this is pretty boring stuff, but bear with me. So there's this thing called the NAICS code, N-A-I-C-S, which is the North American Industry Classification System. There's 7,700 sectors in North American industry that do different things. And some of them are completely irrelevant, like corn milling, doesn't have anything to do with me at this point in the game. But there are all sorts of small segments of industry that this is applicable to, and those companies would be stupid not to apply this approach to their manufacturing. They can get a whole bunch of cheap machines. I'll give you one example. One example would be vacuum forming. So vacuum forming, you heat up a sheet of plastic, you put it over a form, you suck air through the form, and it acquires the shape. It's used a lot in packaging. All of your organically grown produce is put into one of these horrible little plastic bins that's got nothing
Is it
more
called
organic about it.
cryo-vacuum or whatever? Is that the same
I'm
thing?
sorry, what was that?
Cryo-vacuum? I think we call it cryo-vacuum in Australia.
I don't think it's the same thing.
Okay.
This is just vacuum forming, where you're just shaping a piece of plastic over a mold. Cryo vacuum sounds like something else.
Okay. Yep.
Something
yep.
I'm not.
I understand the concept though. Yeah. Continue. Yep.
So when you do that, when you make a plastic part that way, there's flash. There's a big chunk hanging off around the edge that was used to support it while it was being placed over the mold. It has to be trimmed off. And a lot of small businesses, I've worked at one where they did that, and basically they had a router table, they had a spinning bit sticking up out of a table with a guide, and some guy would take these plastic parts and run them past that to trim the edges off. Well, that's a good place to chop your thumb off. It's not particularly safe. It isn't a great job to have. And see, that's something that could be completely automated. You could automate all the trim out for a plastics line. So there's something where there's a very direct commercial application for the technology that I've built, even though that is not what it's intended for. And there are hundreds of examples like that of things that it could be applied to. So there's a phase where these machines could be adopted by industry in a very commercial way to produce revenue, but that's not the point. The point is to get to the next phase, which is where you start to build recycling machines so that all that plastic waste can get fed to these machines. So completing phase 1 is obviously critical, but phase 4 is where the magic happens, and it does not come about until you've completed the requirements for phases 2 and 3. External support equipment so that these machines can process commercially available materials, and the ability in phase 3 to begin to recycle things and produce energy. When you can do all of those things, those are the 3 magic pieces that fit together and make this. And then as far as adoption goes, if industry has begun to adopt phase 1 machines to help with their conventional production capabilities, they're already out there. And a lot of the bugs will have been ironed out, which means that distributing the designs and embedding the expertise that's necessary for those specific applications, all of those parts of the development can occur in the existing environment. We don't have to change anything to get that to happen. And then you can move on to the next 2 steps, which are to redefine how you source your materials, where your energy comes from, and then the last stage is where you start to begin to apply it to transform communities. And by then, we presume that you can buy these things used, buy them secondhand corporate discards that have been auctioned off because they aren't using them anymore. So it's a long play, but the goal is to make modular fabrication machines a norm, at least to some degree, and then each subsequent phase becomes easier when that has happened.
James Jones? Fascinating.
Yes.
I don't know. It's open source. It's incredible. It's that's the magic sauce.
Yep. Well, I want everybody to make 2.
Yeah, I think you just reinvented the alcohol industry. I can see great efficiencies in the alcohol industry now. I'm a fan of alcohol, so the alcohol industry is now reborn thanks to James Jones out there. And where are you, Sacramento or somewhere?
No, I'm in San Antonio, Texas.
Oh, S. I knew it started with an S. San Antonio. Yeah, fantastic.
There you go.
Well, that's James Jones, everybody.
All right. Well, it's been great, and I appreciate that you're getting the word out.
Hey, thank you very much. That's James Jones, everybody. That's Spawn Cube. That's cool. And then that's exactly what we want here on Detonation. Something to take on the fossil fuel industry, take on the financial industry, take on the fat cats, and diffusing political redistributing political capital or political power in the hands of the many. And also, it's really important because you know, I have a geopolitics brain. I'm a geopolitical thinker. I always worry about shipping. It's one of the things that's always on my head because I always toss up between global peace on one hand, you know, the connection between nations, and it makes it harder to go to war, etc., and the fact that it's utterly destructive practice. You know, it's the most inefficient, destructive practice we've ever invented, and it's just a constant battle in my head. But you know what? With the breakdown of Bretton Woods and the reconfiguration of the global economy anyway, I think there's actually a race against time now to get this out there so that communities out there will benefit. You know, I don't think the internet's going to break down on a global scale or anything like that. I think I mean, it's possible. There might be a character event of some sort, maybe, I don't know, catastrophe, I don't know, some sort of solar, I don't know. It doesn't take much to disrupt the global communications sector, but hopefully we're past that. But, you know, if we're not past that, getting these machines out there and proliferating them across the globe as quickly as possible, giving information and the people the information and tools and mechanisms as quickly as possible, so that if anything does happen, they'll be already out there, and you can have local countries, communities, groups that can have these closed circulatory systems of economy is a much better and much safer bet for the future longevity of humanity. You know, it's an existential threat eliminated, essentially, and you have a more peaceful world on the other side of that. So, you know, there's kind of a race against time in a way. Let's get that out there. I'll drop the link in the description. Go down to that link. You know, support this man. Let's do it. Let's, you know, if you know, I'm sure you want to send him an email, I guess, right? Send you an email, yeah.
Absolutely.
Yeah, send him an email. Have a talk to him. I'm sure that he, Mr. James Jones, is very open to listening to new ideas and new conceptions about cube spawn, because I'm very, very interested in this. This is an incredible technology. Fulfills a lot of the requirements of transhumanism and especially of detonation. You know, the subtext of detonation being death and nation. Okay, it's in the title. All right, cool. Thank you, Mr. James Jones. You have been absolutely fantastic, and I really hope to see you soon. And I'll talk to Benzar in 2020 as well. We'll see what we can do for you on the political front. It's not much, but it's something. And also, Mr. Charles Holsopple of Project 222 may or may not be interested. I'm sure he is, because that's a food, water, shelter issue. You know, manufacturing. Let's add manufacturing in there. I don't know. I'll talk to Mr. Holsopple for you as well. Part of that charity. That's fantastic. Thank you very much, James Jones.
Okay, thanks.
Fantastic. Detonation. We're putting death out of business.
All right, cool.